Okay, we're going to try this one more time because I've tried this like 10 times and I can't figure this out, but I think I got it now. This is matter, and matter is anything that's made up of atoms, takes up space, and has mass. So, volume and mass. And that's the key to what matter is. What's a matter? Everything that takes up space and have mass. Here we go. Have you ever seen an atom?
Have you ever seen an atom? Seeing as everything's made of them, you have. But have you ever seen one on its own? Over time, microscopes have become more and more powerful, allowing us to see deeper into the world of the ultra-small. Traditional light microscopes can be used to see things like these onion cells and the structures within them as they divide, pulling apart their chromosomes. But scientists have come up with a whole host of clever methods to observe far smaller things. Using beams of electrons instead of light, we can generate detailed images of chromosomes themselves. Recently, groups of scientists around the world are becoming able to see materials at the most fundamental scale, the atomic. One group from the University of California in Los Angeles have been getting up close and personal with nanoparticles of platinum, just a few nanometers across. Each of the tiny dots you can see here are actually individual platinum atoms. But researchers didn't stop at a two-dimensional picture. By imaging over 100 slices of the nanoparticle at different angles, then removing the noise with a special filter, they were able to map the location of almost every atom. The information was used to create a three-dimensional reconstruction of the whole particle in unprecedented detail. It may look blurry, but this particle is estimated to contain over 27,000 atoms, and so, like flies in a swarm, they appear to merge together. Every so often, though, we see the platinum's atomic structure align, granting us a moment of clarity. This technique is being used to analyze tiny irregularities in the structure of the particle called dislocations. Dislocations are subtle, like the misalignment of the green and red layers of atoms in this particle. But nonetheless, they can significantly change the properties of materials, with effects ranging from a change in the efficiency of LEDs to the strength of metal alloys. Three-dimensional atomic scale imaging like this is bettering our understanding of the structure of materials on this truly fundamental scale.
Wow, that's crazy. So basically, where we're at is we're talking about matter, and we need to understand the properties that go into it to determine what we have. And so, physical properties are stuff that are things you can sense, if you will. So, a physical property would be volume, mass, density, the state of matter, solid, liquid, gas, its color, its texture, its hardness. These are all parts of physical properties of matter. They have nothing to do with the chemical change of a material. If we look at what mass is the amount of measure an object has. Now, here's the deal. Mass is always universal. In other words, no matter where your object is and it's located, it is it is the same. However, weight can differ. So if I'm on the moon, I weigh different than I weigh on Earth. But the reality is my mass didn't change. The amount of volume I am hasn't changed. Okay, what's volume? Volume is the amount of space an object occupies. Now, in this rectangle right here, 5 centimeters by 8 centimeters by 3 centimeters, we have a volume of 123 centimeters cubed. That's easy to take a meter stick and measure that out. And if we break this down, we can figure out what each of these blocks is in volume. But what happens when we have something that's not regular shaped? Well, first of all, just know this. A liquid is not regular shape, so when we put it in a graduated cylinder, it takes the shape of whatever container it's in. If we look at what 1 centimeter cubed is, 1 centimeter cubed equals 1 milliliter. So in this case, this block, if it was a liquid, it'd be 120 milliliters, right? Pretty simple. But what happens if our object isn't like a liquid? it's solid and it has different shapes to it. Well, we can do what we call the displacement method. The displacement method is a method where we take a liquid, take the final measurement in a graduated cylinder, in this case it's 6 milliliters, and we have 4 milliliters to start with. We put the object in, and when we do, it raises up 2 milliliters. In other words, our volume displaced is 2 centimeters cubed, right? Or 2 milliliters. So we subtract the final from the initial, and it gives us our answer. How do we figure out density? Quite simply, we take the mass in grams divided by the volumes, right? And so we have grams per centimeters cubed, or grams per milliliter. That's our volume, right? So mass divided by volume gives us density. How tight are the atoms packed, right? So a cork versus a penny, they have different densities. One floats, one doesn't, right? Why does it float? It's less dense. So pretty good stuff. Use this information to do your labs. Hope you have a fantastic day.